see about our next experiment, which is based upon CNN itself. Here we are going to see how to design and implement a CNN model to classify multi-category TIFF images with help of TensorFlow, and we could also see whether we are overfitting. Do we require any regularizers, or do we require any dropout layers to be applied or not? Okay. Now we have chosen weed detection as our context for this. So we are going to classify TIFF images based on the data set that we have got that has got TIFF files of weed detection in soybean plant. We have got 4 directories for this particular data set: soil grass, soybean and broadleaf. It's easily available on Kaggle, and you have to just load that particular data set and check for the various classifications and pre-process it so as to make to limited image size. Here I am preferring 32 by 32 and of course grayscale image. So array should be flattened and normalized between 0 and 1. So what you can do is you resize here. As you can see, I'm resizing here with 32 by 32 size, and then use your sklearn model selection for training and testing, split, and then you design your model. So here, as we are using a sequential container and adding 2 layers of convolution followed by individually pooling layers, max pooling we are using here. Activation function I've chosen as relu. Then before you pass it on to any dense layer, you would flatten it, and the activation function you could choose is softmax because it's a multi-category classification. So you can see I have used, and again, sparse categorical cross entropy for this loss function, and training and testing is I have used almost 80% of training data, 20% of testing data, and once I put it through several epochs, 14 epochs is what I have chosen here. It was about 90% of accuracy of training and 91 as test, which I find is okay. Now suppose if in case you are having this particular model that I have chosen is giving me a high training and high testing or validation accuracy, perhaps it is not overfitted, but if at all you are choosing some other optimizer and a different type of model, please check if your training accuracy is more and validation accuracy is less. If that is the case, that means your model would be overfitted. Once the model is overfitted, you have to add more dropout layers, or you have to regularize your particular model to do so. Okay, more on overfitting is present in solutions to overfitting topic that I have covered for you. Please go through that. And if at all your model is overfitted, fortunately this particular model is not an overfitted model, but check. If you are using a different optimizer, please check if it is overfitted, then use a regularizer or implement more dropout layers into your model and get the accuracy improved.